On April 29, 2019, the Parkes Radio Telescope in Australia recorded a strange radio signal from Proxima Centauri, the closest star system to the Sun. The frequency of this signal is 980 megahertz, which is usually used by satellites. It has all the properties of radio transmission that are not found in natural sources, and that can only be achieved with the help of artificial technologies. During the observation, this radio signal shifted slightly, which resembled the shift caused by the movement of the planet. What does all of this mean? According to The Guardian, this is the first serious candidate for communication with an alien civilization. At the moment, scientists are puzzled. How can this phenomenon be explained? By a curious coincidence, the exoplanet Proxima B is located in this constellation. It's one of the closest planets known to us where Earth-like life could arise. What are the chances for humanity to colonize this planet? How many people would be needed for such an expedition? And if life already exists there, will the locals welcome us? If there is a form of life in Proxima Centauri, which sends us signals, this should have happened on the planet Proxima B. In fact, it's located in the so-called habitable zone, a conditional area which, according to calculations, provides the planet with conditions as close as possible to those on Earth. The planet orbits at a distance of about 7 million kilometers from its star, Proxima Centauri C. For comparison, the distance between the Earth and the Sun is about 150 million kilometers. However, the star Proxima Centauri C has a weaker luminosity than the Sun, so the local exoplanet receives just enough heat so that water on its surface can exist as a liquid and not freeze into eternal ice. And the local temperature there is probably the same like on Earth. In terms of weight and size, Proxima B turned out to be practically the twin of Earth. It's 1.17 times the mass of our planet. What does it mean for us, the inhabitants of the Earth? Perhaps we should leave cold Mars alone and look for a more attractive candidate for colonization. Is it realistic for a person to settle on Proxima B? My answer is short. It is. But it's very far away, and it is a problem. It's 4.24 light-years away. This flight will be long. The maximum possible speed of a modern spacecraft is about 343,000 kilometers per hour. At this speed, humanity will be able to reach Proxima B in 6,500 years. However, when interstellar travel becomes possible, this time will be reduced to 630 years. If your ancestor, who participated in the Crusades in the 14th century, had gone on such an interstellar expedition, then only now would he be able to land on Proxima B. So I have bad news for you. If you go on such a journey, you're unlikely to live to see its end. But there is good news. Instead of you, your great-grandson in the 6th generation will be able to reach Proxima. How many people will be needed for such an expedition? To calculate the ideal crew for the colonization of Proxima B, French scientists used the Special Heritage Program. It's based on the so-called Monte Carlo method, which calculates all scenarios for the development of events, including the life and death of crew members. Random factors are also taken into account, even disasters and diseases, which vary depending on the number of people who are most likely to be prone to them. As a result, French scientists managed to find out to organize a successful spaceflight to the planet Proxima B, only 98 people are needed, 49 men and 49 women. This number of astronauts will allow the crew not only to survive, but also to produce healthy the offspring and completely eliminate incest, with the exception of the early stages of flight. The optimal fertile window turned out to be the age from 32 to 40 years. By giving birth to children during this period, people will be able to ensure a stable increase in the ship's population and maintain a balance between young and old crew members. In addition, in this case, the epidemic that might occur in the middle of the trip will not lead to the complete death of all members of the expedition. But let me remind you, before the first Earthling reaches the exoplanet, about 6 generations will change on board the spacecraft. Many people will spend their entire lives on a ship. Their entire world will be limited to spaceflight and stargazing. Their immune systems and physiology will be different. They'll never see the sky and the sun. Although it seems to me their consciousness could be immersed in a virtual world where they could get all the vivid earthly experience. What will happen when they finally reach their destination? There are several options for the development of events. The first scenario: there will be no water and air there. First, because of such proximity to the star, an uncontrolled greenhouse effect could have very likely occurred on Proxima B. This in turn should have led to the complete drying of the planet and the evaporation of the oceans. For example, the same thing once happened with Venus. Secondly, in this zone, the planet had to be under the continuous influence of hard radiation and solar wind, which should also have led to the loss of water and atmosphere over time. Third, scientists recently registered a flare that increased the brightness of the star 1,000 times in 10 seconds. To survive such events, Proxima B must have the same powerful magnetic field as Earth and a dense atmosphere. But so far, we know too little about the history of this planet, and recent calculations give hope that it could still preserve the conditions for an Earth-like life. The second scenario: we'll land on an inhabited planet. According to scientists from NASA, Proxima B may still be habitable. If we assume that Proxima B was formed farther from its star and only later on moved into its current orbit, then the planet could have avoided overheating and radiation, saving water and air. In addition, it cannot be ruled out that initially there was a lot of water on the planet, maybe 10 times more than on Earth. Then, even if Proxima B has lost 90% of its water, there will still be enough of it to form an entire ocean. But what about the radiation flare that scientists have recently registered? There's a possibility that initially the planet was surrounded by a dense hydrogen cloud, which took the hit of the star's hard radiation and evaporated, leaving a habitable atmosphere underneath. In this case, our expedition will land on a green planet suitable for habitation. Perhaps there will be intelligent inhabitants on it. How do you think they'll react to earthly immigrants like us? I think that the instinct to survive and defend one's territory is something that is inherent in any living creature. Therefore, even if the locals turn out to be humane, they're unlikely to be happy to share their planet with us. The third scenario: we will face an alternative life form. Usually, when we look for extraterrestrial life, we rely on the fact that it should have formed in biochemical conditions that are similar to terrestrial ones. However, what if life could form even on a planet where there's no air and water? For example, biologist Jack Cohen and mathematician Ian Stewart argue that astrobiology based on the hypothesis of a unique Earth is limited and dismal. They suggest that life could have arisen in other conditions, but not based on carbon. Silicon is most often referred to as an alternative to carbon, and ammonia as an alternative to water. Thus, we can assume that on Proxima B we'll encounter strange, different creatures who were able to build an advanced civilization and send radio signals to other constellations. Who will be more advanced, they or we? Write your opinion in the comments. However, even if we successfully get to Proxima B and the locals meet us, so to speak, with the bread and salt of hospitality, the inconvenient moment that you read earlier continues to bother me. The flight will take 630 years. I don't know about you, but I wouldn't board the ship knowing that I wouldn't make it to the end. What can such a flight be compared to? For example, when the ancient Greeks thought about traveling to Mars, they calculated that even the fastest horse would take tens of thousands of years to gallop there. All the horses in the world at that time would not have been enough, just as now all the energy of our planet is not enough to get to Proxima B in at least 100 years. But the same ancient Greeks could not even imagine that in the year 2021 we will safely fly to Mars, receive regular photographs from there, and organize its colonization. Do you see what I'm trying to say? We understand the universe at some level, but in order to accelerate to greater speeds, we also need to penetrate deep into the atom and understand how it all works. Take chemistry, for example. All rocket fuel is based on chemical reactions, but we still don't know what gravity is, how it works, and what role it plays if you're flying in outer space from one star to another. Someone will sooner or later come up with the equivalent of a modern engine for traveling between star systems. It will be something fundamentally new, which is still difficult to even imagine. And here I have good news for you. Interesting projects already exist. No matter how much we study space, our brain is not able to truly grasp the amazing fact that the universe is infinite. However, a recent discovery may give scientists a reason to rethink everything. Is it possible that the universe has a border? And what kind of flaming wall did NASA probes find on the edge of the solar system? Scientific researchers have long debated the existence of an intergalactic boundary between the solar system and interstellar space. However, until recently, human technologies could not allow us to obtain data from such remote areas. Everything changed thanks to NASA space probes. For the first time, a strange luminous wall on the border of the solar system was discovered in 1992 using the Voyager 1 probe. Back then, scientists considered the existence of this barrier only in theory. However, from 2007 to 2017, NASA scientists launched the New Horizons spacecraft and scanned the sky 7 times to determine the presence of strange ultraviolet light, which Voyager 1 recorded 30 years ago at the so-called border of the solar system. The device received an overview of this ultraviolet emission in the range of 360 degrees and confirmed the registration of excess ultraviolet radiation far from the Sun. Its data is almost identical to the measurements taken by Voyager 1. We see a threshold between the vicinity of the Sun and the galaxy, says Leslie Young of the Southwest Research Institute. What is this threshold, and why was it formed? The fact is that all the planets of the solar system are under the influence of the so-called solar wind. It's a continuous stream of charged particles that are emitted by the solar corona and form plasma. It's this plasma that creates the heliosphere in the form of an elongated bubble around our entire solar system. However, at the edge of the solar system, the solar wind completely dies down, and behind it, interstellar space begins, which is mainly filled with hydrogen. The glowing wall that Voyager discovered is the result of the collision of the solar wind with interstellar forces from uncharged hydrogen atoms. It's assumed that helioparticles colliding with hydrogen lose their speed. Kinetic energy is converted into thermal energy, and a so-called hydrogen wall is formed at the border, which scatters ultraviolet light in a special way. Does this mean that the NASA probe can literally hit the wall? In order to answer this question, let's see what this border is. Scientists have officially named this barrier the Wall of Fire. Let's imagine that we're passengers on the Voyager probe and are looking out the window. Our location is 90 astronomical units from the Sun. The device is gradually approaching the hydrogen wall. The first thing you see in front of you is a zone where the solar wind can no longer withstand the interstellar wind. First, a shockwave appears in the heliosphere, an area in which the wind speed drops sharply, but its density increases. Thanks to NASA research, we already know that the magnetic field here has a strange foam-like structure. This is due to the fact that magnetized matter and small space objects form local magnetic fields that can be compared to bubbles. Then we fly through the heliospheric mantle. Our location is 100 AU from the Sun. This is a zone of turbulence where the solar wind is slowed down and compressed. When the solar wind speed gradually drops to zero, we find ourselves in the so-called heliopause. Here, the pressure of the solar wind is no longer capable of pushing back interstellar matter. Thus, the solar wind mixes with the interstellar wind, and finally, here it is, the hydrogen wall border. Despite the fact that there are no border guards here, it will be difficult for us to fly through this area. We can say that it resembles a real hell. The hydrogen wall contains colossal masses of incandescent plasma. According to the Voyager 2 space probe, the temperature here ranges from 30 to 50,000 degrees Celsius. This hot wall creates a kind of barrier that protects our solar system and prevents about 70% of cosmic radiation from passing through. This is good news, because if such protection fails, we would suddenly be in interstellar space. It's highly likely that we would not be able to survive in such conditions due to the high level of radiation. If that happened, life on Earth would look like post-apocalyptic or nuclear winter movie scenes. However, the solar system border has a more interesting feature. It has a low density, so NASA probes can pass through it. The main task is for the equipment to survive the flight through the hot plasma. So far, a piece of Voyager 1's equipment, which is responsible for data transmission, broke when trying to fly through the hot plasma barrier. Therefore, now all our hopes fall on Voyager 2, which, according to the latest data, has not yet reached interstellar space and is temporarily stuck in the transition zone. NASA scientists continue to receive signals from it, but at the moment are not sure if it will ever be possible for humans to travel through this barrier of burning plasma. So far, we cannot predict how interstellar radiation will affect spacecraft passengers. But suppose our technology made such a flight possible. What would happen when we fly through the plasma? So let's imagine that we managed to accomplish the impossible. We crossed the border and, in a sense, found ourselves in a new reality, which no longer has anything to do with life in the solar system. What will happen next? So far, we can only guess about it. There's a hypothesis that a head shockwave awaits us behind the wall. It has the shape of an arc of a stretched bow and looks like a wave that occurs on the water's surface in front of a moving vessel. The head wave will arise if the interstellar matter moves towards the Sun at supersonic speed. However, this wave may not exist. A study published based on the analysis of data from the IBEX probe indicates that the speed of our heliosphere through interstellar matter is not fast enough for this. These conclusions are confirmed by the data of the Voyager spacecraft. But in order to find out what exists there beyond the hydrogen border, we'll have to wait for new data. And now it's time to return to the question posited at the beginning of the video. Does the universe have a border? Since we found out that our solar system has a visible border, a logical question arises. Can we apply this pattern to the entire universe? The fact is that over the past few years, there have been many scientific discoveries that give us more and more interesting hints that the universe is not infinite. For example, if we assume that the universe is infinite, then we should talk about its infinity not only in space, but also in time. This means that such a universe would have to have an infinite number of stars. However, when you look at the sky at night, you see dark gaps between the stars. This tells us that the cosmos has not existed forever, and according to the Big Bang Theory, there's a point in time at which the universe begins. Our world has not always existed, and all this refutes the theory of the eternity of the universe, and accordingly, its infinity. The problem is that long-distance travel takes light years, and so scientists always get outdated data. Moreover, we don't see all galaxies. 13 billion years is the maximum available to us, says Neil Cornish, an astrophysicist at Montana State University. Thus, there's a barrier of relic radiation for our vision. It was formed 380,000 years after the Big Bang, when the universe expanded and cooled so much that atoms appeared. This radiation can be compared to a childhood photograph of space, where it was captured before the stars appeared. However, behind this barrier there could be either borders or an endlessly continuing universe. We cannot get unambiguous data whether the universe has an end or not. But using mathematical calculations and exploring the microcosm, scientists have already built working theories and even suggested what shape the universe actually has. You can find out more about this in a video that I released earlier. Are you interested in learning about a distant celestial object in the far reaches of our solar system on the threshold of deep space? Do you want to see another world, many of whose phenomena defy rational explanation and understanding? Then get ready for a long journey, because the chosen celestial body is located millions of kilometers from Earth. Welcome to amazing Triton, Neptune's most famous moon. Due to its considerable remoteness, very few probes have studied Triton in the entire history of astronautics. To be more precise, only Voyager 2 has flown past this celestial object. That happened back in 1989 as part of a transit journey past Neptune, the parent planet of the icy moon. Here's the first photo of Triton obtained from the Voyager spacecraft. The image is singular and exceptional, as the Earth had never before received anything quite like it, especially from such an enormously distant locale. So, what exactly is it, this cold and nearly inaccessible world, Triton? Despite the short meeting, Voyager 2 discovered a number of unusual phenomena on the celestial body, for which modern science has not yet given intelligible explanations. As mentioned previously, this Neptunian satellite was revealed to the world in all its glory by the legendary Voyager 2 probe. It's noteworthy that Triton was the last object seen by Voyager 2 in the outer solar system before the spacecraft crossed its borders into the farther reaches. Unfortunately, the probe was able to capture this mosaic of images of only one of the hemispheres, the one facing Neptune at the time. The craft's short transit time through the Neptunian system simply didn't allow for more. From first glance at the numerous photos, it became clear the moon is one of the few geologically active objects within the outer solar system, and its surface is relatively young, its age not exceeding 100 million years. Unlike most solar system moons, Triton rotates counterclockwise and takes the place as the seventh largest of all moons in a relatively close environment. It's generally assumed that this celestial body is an alien to this system, having come from the Kuiper Belt long ago, later being gravitationally captured by Neptune. The first surprise that Voyager 2 discovered was the presence of a rarefied atmosphere around Triton. The cloud layer above the moon is approximately 100 kilometers thick. Measurements have shown that the atmosphere is predominantly nitrogen, with small inclusions of methane and carbon monoxide. Strikingly, its pressure, which was about 19 microbars when measured by Voyager 2, has increased significantly according to 2010 data and now varies from 40 to 65 microbars. The mechanism behind this phenomenon remains unclear. What can be said about the surface of Triton? It's very unusual. To understand this, Voyager 2 needed just the one short meeting with the celestial body. There are 12 types of terrain on the moon, from chains of craters and strange potholes to vast plains and cryovolcanoes. The image presented here shows dark spots, the consequences of the cryovolcano eruptions. Near the equator, the probe found an interesting object, similar in contour and structure to a frozen lake roughly a kilometer deep. You can see here that there's a small impact crater on its surface. Such formations may indicate that liquid has existed on Triton for centuries. The moon resembles a huge piece of ice with a diameter of 2,706 kilometers. The temperature on the surface reaches an incredible minus 235 degrees Celsius, which makes this body the coldest in the entire solar system. It's so frosty that even nitrogen falls in the form of frost and snow on the mountain slopes and valleys of the mysterious moon. During the visit to Triton, its polar cap was revealed to be truly huge and covered a significant part of the southern hemisphere. According to the data obtained, it consists of a mixture of nitrogen ice, methane, and carbon monoxide. Another important question: how is this hemisphere cratered? Voyager 2 discovered only 179 craters, while on Miranda, which is just 3% the size of Triton, 835 of them were recorded. This is in conjunction with the fact, as mentioned earlier, that serious geoactivity is indicated on this Neptunian satellite. Additionally, the interplanetary probe discovered something unusual and mystical on Triton, namely, a surface that's not found anywhere else in the solar system. This is cantaloupe terrain, or melon peel terrain. What provoked the formation of such a strange relief pattern? This location is considered the oldest on Triton. The area is completely covered with huge structures up to 50 kilometers in diameter, with rather smooth and high edges. Surprisingly, the funnels are characterized by a pronounced curvature, in contrast to the clear forms of standard craters. There are many theories as to the origin of such a relief, and one of them claims that its origin is associated with very powerful cryovolcanic emissions that periodically flooded this area, melting the icy crust. Later, it's theorized the substance hardened and cracked. Cryovolcanoes are an unusual phenomenon from the point of view of orthodox science. Their appearance is possible only under conditions of extremely low temperatures, when mountains erupt and instead of molten rocks, spew water, nitrogen, and other substances in both liquid and gaseous states. These Voyager 2 images show one of these eruptions 45 minutes apart. In the blurred image, a plume of particles can be seen rising up to 8 kilometers and drifting with the wind for a distance of about 150 kilometers. But where is enormous Neptune, which should be reigning supreme in the skies of Triton? The probe did thankfully capture this image of the blue planet. Here you can see what the gas giant looks like from the surface of the moon. It even shows the global hurricane known as the Great Dark Spot. The Voyager 2 probe succeeded in the impossible. The images it sent allowed scientists to create a relatively detailed topographic map of the distant moon's terrain. In particular, the following 10-kilometer resolution image helped tremendously in achieving this goal. But, alas, all things come to an end sooner or later, and so the fruitful mission of the probe inevitably came to its conclusion. Throwing a farewell glance at Triton, the apparatus literally flew away into the distance and night. If you look at this picture impartially, you might think that we're not facing the icy moon of Neptune, but our very own satellite. As you may know, Voyager 2 also carried on board a golden plate with recordings of human speech, the roar of volcanoes, the whisper of ocean surf, the voices of birds and animals, as well as playback of famous musical passages. But on Triton, apparently there's no one to hear these magical sounds, although astronomers do suggest the presence of a subglacial ocean on Triton, similar to the one that probably splashes under the crust of the Jovian satellite Europa. According to assumptions, Triton's subglacial ocean's temperature doesn't exceed minus 97 degrees Celsius, and it consists mainly of water and nitrogen. And it's true that in such a harsh reservoir, it's unlikely that life, at least as we know and understand it, could have originated there. Meanwhile, Voyager 2 is still continuing its journey through the inky darkness of space, and we should think on the following. If Earthlings don't organize missions to Triton in the near future, then after some while, due to the tidal influence of Neptune, the moon will gradually approach the planet, having reached the Roche limit, and will inevitably collapse down onto its gaseous parent planet. The moon will be torn apart, and a system of rings will appear around Neptune, several orders of magnitude more epic than those of Saturn. It will be quite a show. In this case, Voyager 2 will remain the first and only device to visit Triton at the outskirts of the solar system. We live in an age of active space exploration, but the process moves significantly slower than the growing human thirst for knowledge. Think of the probes sent to the planets of the solar system. Which one comes to mind first? The Voyager brothers, Mariner 10, New Horizons. But you didn't guess. Today we'll talk about the mission of the Galileo project, which has become key in the study of Jupiter. The Fearless probe managed to record a unique collision of a comet with a gas giant, the thick ammonia clouds and the poisonous atmosphere of the huge celestial body. It became the first device to enter the orbit of Jupiter and also extensively studied the celestial giant and its moons. And even this is not a complete list of Galileo's achievements. Although its mission has long since been completed, this does not detract from the huge contribution that the probe made to the development of astronomy. When did the amazing story of the spacecraft's creation begin? Astronomers began to implement the project back in the 1970s. Then it was simply called the Jupiter Orbital Probe. At first, scientists couldn't get enough funding to carry out this mission, but the engineers achieved their goal by connecting all available connections. Despite initial success, no one gave guarantees that the material support of both the project itself and the laboratory wouldn't stop. That's why the mission took more than 10 years to complete. Initially, it was supposed that the probe would go to the orbit of Jupiter using the Columbia Space Shuttle, but the idea was not implemented due to the protracted development of the craft. Then the researchers decided to postpone the launch of the probe for several years, but soon they had to postpone it due to the tragedy with the Challenger. The object exploded along with the astronauts on board. 7 people died in the terrible accident. The world was in mourning for a long time, but as the wise King Solomon said, everything passes. And now on October 18, 1989, finally, the Galileo Automatic Interplanetary Station went into outer space using the Atlantis shuttle. First, the device headed towards Venus to gain additional speed. The probe didn't just fly by, it seemed to be examining the composition of the clouds that surrounded the foggy planet. After that, Galileo made 2 more gravitational maneuvers not far from the Earth. In addition, this helped to obtain more extensive information about asteroids. The first photographs taken by Galileo captured the Gaspra asteroid, which became the first such object to which an earthly research apparatus flew so close. And here are the images of the Ida asteroid. It turned out that despite its small size, it has a moon called Dactyl. A closer look at Ida even revealed craters. Up to this point, scientists had not recorded the presence of an asteroid of its own moon. What else did the probe manage to do during the second gravity assist? Galileo also scanned the moon with an ultraviolet spectrometer. This made it possible to better understand the nature of changes in the lunar regolith under the action of solar radiation. Next, the Galileo orbiter got enough speed to head straight for Jupiter. What made the mission successful? In 1994, Galileo was able to detect fragments of the Shoemaker-Levy 9 comet, which were about to enter Jupiter's dense atmospheric layer. The researchers could not observe the epic disaster directly because the fragments were moving from a side invisible from the Earth. Galileo made it easier for scientists and provided the opportunity to observe this event. Later, the collision and its consequences were recorded by the Hubble telescope. Thus, this was the very first observation of a comet's encounter with the surface of a celestial body. Do you think the amazing discoveries ended there? Of course not. On July 13, 1995, the greatest event in the history of astronautics took place. The descent vehicle left the orbital module and headed for the poisoned clouds of Jupiter. At this time, Galileo was collecting information about temperature fluctuations, atmospheric components, and the spread of radiation on the gas giant. The last point, from the very beginning, represented a significant danger to the probe and the mission as a whole. Approximately 60% of the total radiation the device received in just 1 hour of data collection work, staying at a small distance from the planet. But this was not the only trouble. In addition, the normal operation of the apparatus was hindered by the so-called electrostatic discharges. How great the threat was and how it would affect the operation of the probe, it was impossible to know in advance. Everything was decided only on the spot. So, in December 1995, Galileo flew at a very close distance from Io, Jupiter's moon, whose gravity helped move the probe to the desired orbit. A few hours later, the orbiter received signals from the descent probe, which found itself in the atmosphere of the gas giant. In less than an hour, astronomers were able to verify that the probe was fully operational and capable of collecting data obtained by monitoring Jupiter's atmosphere. Scientists breathed a sigh of relief because their many years of painstaking work did not go to waste. Do you know what happened after this news? Thunderous applause broke out. By the way, the number of people working on the implementation of the mission reached 10,000, so we will not strictly judge the scientists for their emotions because they are quite understandable. Something unprecedented happened. The Earth probe plunged into places where no man-made apparatus had ever gone before. So, what awaited the probe in this hellish realm of indomitable hurricanes and sulfurous rains? When the device entered the atmospheric layer of Jupiter, its speed reached about 47 kilometers per second. Almost immediately, due to the cone-shaped protective screen, the probe began to slow down. Later, a special parachute with a diameter of 2.5 meters provided a decrease in speed. The deceleration process significantly heated the surface of the probe. The temperature of the special plasma layer covering the protective screen reached 14,000 degrees Celsius. The indicators of aerodynamic forces acting on a small apparatus were monstrously high. These were a record, and one might say marginal values for a landing device ever entering the planet's atmosphere. Before opening the parachute, the probe dropped the tail cone and fragments that remained from the protective screen. This happened at a distance of about 18 kilometers from the edge of the cloud layer. Further, for the rest of the time, the device continuously collected data on the atmosphere of Jupiter and transmitted it to the orbital module. As a result, the probe passed through a layer of the atmosphere, which included minor fragments of ice and hydrosulfide, as well as clusters of clouds, apparently consisting of frozen ammonia. As it turned out, there was not as much water in the atmosphere of Jupiter as it was assumed before the start of the mission. Later, scientists suggested that the device descended in a place where the atmosphere was drier than in other parts of the planet. In another way, such an area is called a hotspot. Last year, NASA confirmed this theory based on data from the Juno spacecraft, which began exploring Jupiter after Galileo. Most likely, the chemical elements and substances in the atmosphere of the gas giant are not well mixed with each other, so their concentration differs depending on the location. How can one appreciate the desperate journey of a fragile Earth probe into the Jovian atmosphere? Although the voyage was planned only one way, which suggested the death of the device in the clouds of Jupiter, the results of the mission are unambiguously positive. After all, the information obtained has shed light on many hitherto unknown phenomena. Further studies of the gas giant may give us more information about the early periods of the solar system. It's quite possible that Jupiter was the first to form, and its composition contains particles of dust and gas that were not absorbed by the sun. What other events that happened with Galileo are worth mentioning? During the flight, the probe encountered such a phenomenon as lightning. Lightning isn't so common on Jupiter, but its power is immeasurably high. And if we add to this the wind speed of 640 kilometers per hour, then a rather frightening picture emerges. Jupiter's lightning is formed by the action of as of yet undiscovered hot regions located in the inner layers of the planet. The probe also recorded an intense radiation belt unknown to modern science, located at a distance of about 50,000 kilometers from the top layer of clouds. In addition to a high level of radiation, much higher than in other belts, scientists have found helium ions, the origin of which could not be established. The device stopped collecting data after entering a turbulent layer with a temperature of about 153 degrees Celsius and a pressure of more than 20 bar. Probably the atmosphere, which consists mainly of hydrogen and helium, got inside the device. That is, the probe lost its seal. Thus, the short but fruitful existence of the landing probe ended. Meanwhile, the Galileo orbiter moved into a highly elliptical orbit, thus becoming an artificial moon of Jupiter. Be that as it may, the probe overcame incredible difficulties along the way, provided valuable data on the atmosphere of Jupiter, and forced scientists to disprove many established theories. Surely you've watched at least one science fiction or fantasy film where the main characters travel into the underworld. But it's all fiction. How are things in reality? What is deep underground? What are scientists going to find out about the lower layers of our planet? Does the name Kola Well mean anything to you? What is it? And why are some people still convinced that this is not a well, but an entrance to the house where the devil lives? You might think that people started drilling wells and boreholes only in the last century, but in fact this isn't so. The first wells were dug between 7,000 and 10,000 years ago during the Neolithic era, and the first coal mines were dug between 20,000 and 40,000 years ago in Africa. Wells, pits, mines, and boreholes often contain many unknown and mysterious things. Every year, scientists find something amazing in one of them. For example, quite recently, Russian, French, and German researchers, when drilling a deep hole, found an ocean underground that existed during the Archean period. Its depth is about 500 kilometers, and in terms of volume, it was larger than all the oceans on our planet combined. So, scientists learn more precisely how the Earth was formed, and that's all due to the drilling of deep wells and boreholes. In 1970, the Soviet Union celebrated 100 years since the birth of Lenin. It was then that the Soviet scientific community began to work on one of the largest projects in the history of the country. They started drilling a well, also known as the Kola Super Deep Borehole on the Kola Peninsula, which entered the Guinness Book of Records as the deepest hole ever dug. It's difficult to overestimate the importance of this object to the world of science. Over just 20 years, scientists received tons of useful information about the structure of the Earth, the origin of minerals, and much more. Let's go a little deeper into history. On the Kola Peninsula, the drilling rig was a massive facility in its heyday, allowing it to accommodate 3,000 workers at a time. The most advanced scientists of the country also worked there. It would seem that everything was going along fine, even getting better day by day, when suddenly the huge facility stopped working. The accident gave rise to many guesses and rumors because the drilling business was clearly going well, and no one else in the world could boast of such an unfathomably deep well, one that reached down more than 12 kilometers. Some people assumed that otherworldly forces were to blame for the drilling stopping, and insisted that demons and devils had also appeared on the Kola Peninsula. Well, the lower layers of the Earth are poorly understood, so who knows? Maybe there is some kind of hell down inside of there. This could be the cause of many inexplicable things. For example, several times when workers removed a drill from the borehole, the end turned out to be melted. You might say that at such depths, the temperature is simply too high, but this isn't true. In fact, it was no more than 200 degrees Celsius. The drill could easily withstand such temperatures. So, what melted it? The oddities didn't end there. It turned out that there are quite clearly audible and truly frightening screams and groans in the audio recording from the bowels of the Earth. People who've worked with such materials before have repeatedly admitted that they were on the verge of an inexplicable and terrifying panic when listening to the recordings. Not surprisingly, work stopped after this. Many people did not believe the rumors, but did change their minds after an explosion in 1995. Then many questions were raised, but the most important one was, what in bejesus could have exploded? Even the chief geologist of the facility, David Huberman, shrugged. If this isn't evidence for the existence of hell, then what is? Sounds intimidating, scary, and quite remarkable. And I agree. And how could you not believe it? But in fact, it's all very simple. This whole scary story part was invented by a Finnish journalist as a joke on April Fool's Day. The American press didn't get that it was a joke and printed the entire story in all seriousness. So, a fictional story went out to the masses as pure truth. Although nothing supernatural happened at the Kola borehole, its history is actually quite exciting in itself. Let's start with an explanation for why such projects as the Kola Super Deep Borehole were developed at all. It's all quite simple. There are layers under the Earth that could not be studied before this due to a lack of technology to access these places. Some discoveries help us to learn more about the formation of life on Earth and more as well. For example, the United States has drilled 86 wells in Antarctica. What for? To explore space. Yes, you heard that right. The thing is that now scientists are actively studying the neutrino, a stable neutral lepton that takes part in weak and gravitational interactions. To explore its properties, it must be separated from other elements. It's impossible to do this on the Earth's surface, so American scientists created filters in these wells where ultra-sensitive devices are located. Due to these filters, such facilities are capable of detecting neutrino remnants that pass through the Earth, filtering out everything else. But back to the Kola well. Why was this place chosen for drilling? The Kola Peninsula is located in a place where formations of the Precambrian period are located, and there are no sedimentary rocks in the upper layers. The borehole was drilled there not for mining, but in order to confirm the structure of the Earth, which scientists knew about only in theory, to get more information about the structure of the nickel-bearing petchenite complex, and to find out what some rocks are made of. As we said above, the project was launched into development in 1970, and the drilling process itself began in 1972. The first 7,000 meters were passed without much difficulty, since at this depth there were only homogeneous granites. Having passed these rocks, the drill got into rocks that were not so strong, and voids constantly formed there. The apparatus could not move further because it constantly got stuck, and part of it often became disconnected if workers tried to pull it back up. But that didn't stop the drilling. As a result, in 1979, the Kola Super Deep Borehole became a record holder, reaching a depth of 9,500 meters. But this was not yet the limit, and 4 years later, the depth crossed the 12,000 meter mark. To give some perspective, that's deeper than the Mariana Trench. What did scientists discover while drilling? Firstly, deposits of copper-nickel ores were found, and these could be mined. Secondly, at a depth of almost 10,000 meters, geologists stumbled upon layers of high gold concentration. Such a phenomenon is considered anomalous, but anyway, gold cannot be mined from there. However, this discovery made it possible to gain a clear understanding of the process of gold formation. Also, in the process of drilling, scientists discovered 14 types of fossilized microorganisms. Amazingly, the age of some of the layers goes back almost 3 billion years. This suggested that the Earth had existed for much longer than previously believed. At the beginning of the last century, scientists formed an idea of the Earth's composition. However, no one could say exactly how wide each layer was. When the drilling of the Kola well began, we finally got an answer to this question. In the first 4 kilometers, the structure was what was theoretically expected. But then it was anticipated that the drill would reach a layer of solid basalt rocks. However, there was no basalt there. Instead, they found crumbling rocks, due to which it was difficult for the apparatus to move further. Methane deposits were also discovered. This helped us to better understand how oil and gas hydrocarbons are formed. But that wasn't all. A Soviet research team obtained soil samples on an expedition to the moon. In the course of its study, it turned out that its composition and the composition of rocks from layers at a depth of 3,000 kilometers are identical. How could this even be possible? According to one version, the Earth collided with an unknown cosmic body many billions of years ago, and part of the Earth broke off and became a satellite, what we know of now as our lovely moon. And it's possible that the split occurred in the place where the Kola Peninsula is now located. One question remains open. Why was the Kola Super Deep Borehole shut down in the end? Obviously, mysticism is not involved here. The explanation is much more prosaic. Scientists conducted all the studies they had planned, and at that stage there really wasn't much more that they needed to figure out. And the situation in the country was, at the time, not conducive to financing new or extended scientific projects. The government simply could not continue to fund such a large-scale undertaking. So a huge number of the workers resigned, and most then left the peninsula. But be that as it may, the Kola Super Deep Borehole has made a huge contribution to the development of geology and science in general. Despite many difficulties, scientists have learned much more about the structure of the Earth, the properties of minerals, and the age of our planet. Even now, after almost 20 years, the Kola well surprises with its scope, and I, for one, simply refuse to believe that research will no longer be carried out there. The chief geologist of the project at the time, David Huberman, once said, "We have the deepest hole in the world, so we must use it." Who knows, maybe the day will come when the Kola super deep borehole will start working again. Time will tell.